So just a recap first, because it has been a long time. So what is an acid? We are going to follow Bronsted-Lowry definition, and it is like an acid is something which can give a proton, right? An acid is a species that can give a proton, right? That is how we define an acid. And how do we define a base? Well, a base is defined as something which can accept a proton. So an acid loses a proton, a base gains a proton. Similarly, we can look at the reverse reaction also. And in the reverse reaction, Cl minus is the base, H3O plus is the proton. Then we looked at reversible, irreversible reactions. Reversible reaction is reaction which can, you know, go from A plus B to, it can form C plus D, and C plus D can also react to give A and B. Irreversible reaction is something in which this is not possible, right? Only A plus B can react to give C and D, but C and D cannot react back and give A and B. So that is the basic difference between these two, right? So now another important concept what we discussed was the concept of conjugate acid base pairs. So what exactly are we talking here about the conjugate acid base pairs? Well, the conjugate acid base pairs, whenever I'm asked to draw a conjugate acid, I will simply add H plus. If I'm asked to draw a conjugate base of a species, what I will do, I will simply take H plus out from the species. A base and its conjugate acid, well, again, as we can see here, right? Same thing. If I'm asked what is the conjugate acid of NH3, I will simply add H plus and then we are done with it, right? So these are the things what we have to do, right? So next thing is NH4 plus is the conjugate acid of NH3, right? This is pretty clear. H2O is conjugate acid of HO minus. HO minus is conjugate base of H2O. NH3 is conjugate base of NH4 plus, right? So these things are very, very important, all right? And we went through them, right? Then this is a very, very important concept. Stronger the acid, the weaker is its conjugate base, right? The stronger acid has weaker conjugate base, right? So if I know that HBr is a stronger acid than HCl, so I know that Br minus is a weaker base than Cl minus. Then we did this question, which of the following are not acids? Well, this is very clear. CO2 and CCl4, since they do not have acid, right? They do not have hydrogen, they cannot be acids, right? So this is how it is, all right? So now, and then the problem 3, right? Also, which what we did was, what is the conjugate acid of the following, right? We simply add H plus and we get the acid. What is the conjugate base? I take H plus and we get it. So I'm just doing a quick revision, right? pKa and pH. Well, we can see in the top reaction, the big arrow is in the forward direction. It means that a large portion that this particular reactant have reacted, and they will give more products as compared to when product reacts to give the reactant. And in the bottom reaction, in this particular one, what will happen? Well, here we can see this arrow, this back arrow is greater. It means that the forward reaction will not take place to a considerable point, and what will happen? Well, the backward reaction will be dominating, right? Backward reaction will dominate here. Okay. So HCl is a strong acid because it is giving us more products, and CH3COH, acetic acid, is a weak acid. Then we learn how to write the equilibrium constant, and then I said that when we have to write the acid constant, we remove the water, right? And we just write it like this. Defining pK, pK was negative log of K. If you remember, then we learned how to use the log, how to calculate the log in the, right? So that is important, right? So let's see. Very strong acid, pK less than 1. Moderately strong, 1 to 3. pK weak acids, 3 to 5. Very weak, 5 to 15. And after that, extremely weak acid, pK greater than 15. Defining pH, pH is equal to negative log of H plus. Do not confuse pH and pK. So this was a strong question, which is stronger acid, one with the pK of 5.2 or one with the pK of 5.8. We know that stronger acid will have less value of the pKa, right? So we know that the stronger acid is the one which has the pK 5.2. Okay. And problem B, which is a stronger acid, one with the K this or one. So the greater the value of K, equilibrium constant, it means stronger is the acid. So whatever has the large value, right, that is going to win as the acid. That is also, this is also fairly clear. Okay. So, and then I asked you to do these, and yeah, we did. Are the following fluids acid or basic? Well, we know if pH is greater than 7, they are basic. pH less than 7 are acidic. And if pH is equal to 7, then what we have is that they are neutral. So bile, basic, urine, acidic, spinal fluid, pH equal to 7.4. It is slightly basic. Then we looked at the statue of George Washington, and he has been damaged by the acid rain. Acid rain has H plus, which reacts with the CO2, the carbonate, and it's like, yeah, it has destroyed the statue. It is destroying a lot of aquatic life also. Then we have organic acids and bases, carboxylic acids. So I asked that what you have to do is that you have to gradually remember these values, right? Do not force yourself yet, but it will become a habit as we go on, right? So acetic acid pK nearly about 5, alcohols. You can see methyl alcohol, ethyl alcohol, amines, these values, protonated compounds, protonated compounds. So let us see how much you have retained. Then we talked about this curved arrow. Well, this is the hemlock, and this is what was used to poison Socrates. Okay, drink made of hemlock. So, and yeah, hemlock is an example of a plant. It contains 8 different poisonous amine, and the most poisonous one is this conin. So yeah, alcohols, carboxylic acids, and again we talked about these curved arrows, and we said that yeah, these curved arrows we have to draw. They are always drawn from the lone pair of electrons. They always start from the base and they go towards the hydrogen of the acid. Okay, we'll learn to draw them later. And then we said that this is how we calculate the formal charges on each of them, and we should be able to draw them, right? And these were the, again, same thing, curved arrows. The drawing continues. Okay. And the important thing is that you have to remember the pK values, and we remember the pK values in terms of in multiples of 5. So less than 0 are the protonated species. When the species are protonated, what is happening? We can see that the pK are less than 0. Whenever oxygen is protonated, oxygen has a positive charge and a hydrogen attached to it, the pK value will be less than 0. Okay. Then approximately 5 is carboxylic acid. All right. So, yeah. Then protonated amine is pK 10, and then alcohol 5. So, at an interval of 5, we are trying to get them right. 5, 10, 15. Again, you need to remember these values. You need to remember these approximate values because they'll be very important when we learn about the reactions, which we'll do later. But for the meantime, you do not need to force yourself to remember. But yeah, we can look at the table and we can do this. Okay. So I just want to see if you still remember things. I wanted to do 10, 11, and 12 and send me your answers quickly. Okay. Has Joanna also joined?
No, sir.
Okay, don't worry. Okay, then please keep going.
Sir, I think we've already done these before.
Sorry?
I think I've already done 10, 11, and 12.
No, no, no. It's not about already. I wanted to see if you are still know the concept. I know that we have
Oh,
done. We know that we have studied this. Okay.
okay, okay. So I'll just do it again.
Yeah, yeah, yeah. I want to see. Right. There are a lot of things which we have done, but when I ask again, then it's already gone from the
Yeah.
right.
Yes.
And it has been a long time. So this is what I want to check. Don't look at previous answers, please.
Yes, sir.
You can open the notes. You need to use them in order to answer problem 12.
Yes, sir.
First one is approximately 36, 38, right? In 12.
I'm still doing 11B.
Okay. Sanchita, you are there or your turn came? I think her turn came.
No, sir, I'm still there.
Okay. So why are you at dentist? You have braces or what?
To get actually, I don't know what we're doing today. It's either a checkup or they'll put the lower braces.
Okay.
No, sent it.
Okay. Great. Okay, conjugate acid first is correct, second is correct, third is also correct, fourth is correct, fifth is also correct. Very good. I'm very happy, Sanchita, especially the way you are drawing the structures. This even my best students are not able to draw so neatly, and very nice, very, very good. Good handwriting. Clarity is needed, right? 11 ACH3, but also try to get the unruled notebook, because you see, in organic chemistry, which we are going to study further, you will be needing a lot of lines. So, it's better. You'll feel clear. You'll see. Okay, this 11A CH3. Okay, very nice. This is also correct. CH3 and CH3OH with HCl. It is acting as a base. Very good. Okay, this is also correct. Next is this. This is also correct. Okay, 40. Okay, B. In the B, it is alcohol, Sanchita, so it has to be 15. Okay, near about 15, 16, not 5 as you have written. The C one is a carboxylic acid where there are two oxygens. That one is 5. So B is incorrect. So the D is correct. Okay, very good. Next is I'm waiting for answers from Ananya. Okay, Ananya, where are the answers?
So 1 minute, I'm on
Okay.
12th one.
Okay.
So I sent the answers.
Okay, let me check. Oh, very good. You have the unruled notebook. Okay. First one, CH3CH2OH2 plus. See, in the first one, you have to write CH3CH2. You have missed 1, 2 in the product right hand side. And
Oh,
also, when we are adding H plus, it will become CH3CH2OH2 plus, right?
yeah, I forgot the plus.
Okay, CH3CH2OH2 plus. In the B one, it is CH3CH2O minus. You have to write. See what is happening here. If it is neutral, see, I've also written here. Z plus H plus ZH plus Z minus H plus ZH. Charge must be conserved. So if I'm adding H plus here, for the A, it will become CH3, CH2, OH2 plus. For the B, since it is negative charge, when I add H plus, plus and minus become 0. So it will become CH3, CH2OH. In the C, you have again missed the negative, Ananya.
Yes,
It
sir.
is CH3COO minus. And you write like this. It will always help everyone. Plus H plus. No need for any shortcut. For example, the part A we can write like this: CH3CH2OH plus H plus. So this will be CH3CH2OH2 plus. Okay, same in D, Ananya, we have to write CH3CH2 NH3 plus, right?
Yes, sir.
In the E also it will be OH2 plus. Party, huh?
Oh,
In the part E also, it will be CH3, CH2, COOH2 plus, right?
yes, sir.
That is one thing. Now 11 part A. Again, in the product, it will be CH3O minus and NH4 plus. Huh?
Yes, sir.
And in the product, when we are writing CH3OH plus HCl, it will be CH3OH2 plus and Cl minus, right?
Yes, sir.
Okay, bache. No worries. And in the B part, NH3 plus CH3. See, the charge must be same on the left hand and the right hand side, but that does not mean we just write 0, 0. Sometimes, they will become neutral. In the B part, it will be NH2 minus because H plus it has given, so it will become NH2 minus and CH3OH, right? NH2 minus it has to be, huh?
Yes, sir.
In the NH3 HBr part, that is correct. Okay, let's check the pH 40, 15, 5, and 10. Okay, that pH is correct. But okay, very nice. But be careful about the
Yes,
charges.
sir.
That is the main thing. Okay, let's practice some more. Come on, come on. I knew this is going to happen. So first, let me go here and yeah, let us practice. First, we'll leave this. We'll go to others.
Sir, I need to go.
Sure, 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 sure.
I'll join back later.
No problem. No worries. Huh? Okay. I'm recording it. Okay. Yeah. Bye. Okay. Ananya.
Yes, sir.
So we have to go and we have to just do this, whatever I'm taking. First do 55th. Okay.
So only the A part?
Yes, yes, only the.
The larger Ka means that it's a stronger acid, right?
Yes, yes, yes. So, what are the plans for today, Ananya?
So nothing much.
Nothing much. Not going anywhere,
No.
huh? Okay.
So I sent the answer.
Okay. Very good, very good. Do 61 then.
Yes, sir.
Very good.
So does the equilibrium give you the weaker acid or the stronger acid?
Well, equilibrium always goes to the weaker acid side,
Okay.
right?
Yes, sir.
From strong acid to weak acid, right? See, you forget things, Anna?
Yes, sir, a little bit.
Yeah, yeah. That is why we must revise.
Yes, sir.
I think I've sent you the answers also, right?
Uh, Let me check.
For
I
this.
don't, so I don't remember.
Yes, I've sent.
Oh,
I
yes, sir,
guess.
you sent it.
Yes.
Sir, in option D, aren't both of them acids?
Sorry?
So, so in option D, CH3, CH2OH, and HCl are acid.
Yes.
So,
This. So which will act as an acid? Which is stronger acid? Is obviously HCl, right? So this will
yes, sir.
give proton and CH3, CH2. It will act as base. It will accept the proton, and this will be the proton. Okay.
Yes, sir.
Okay. I think you're done with this. You can send me, huh?
Yes, sir. And one second.
Okay, we'll come to this. We'll have this tutorial. Notice that a neutral acid forms a negatively charged conjugate base, whereas the positively charged acid forms a neutral conjugate base. The difference in charge decreases by 1 because the acid loses H plus. This is the important part. Okay. So see how they are doing acid conjugate base, acid conjugate base. Huh? Now you have to draw the conjugate base for the following acids.
So what are we doing?
We have to do the problem 1. So you'll go again or you're done for today, dentist?
So what?
You're done for today with the dentist?
Yeah.
Okay, cool. Problem 1 we are doing. Huh?
Okay.
Sorry, sorry.
Cool. Let me check. Very nice, very good, very clean. Okay, nice. Okay, Sanchita, you're done?
Yes, sir, I'm done.
Okay, we'll go to the next then. Yes. Okay, problem two. Nice, nice.
Sir, I sent the second one.
Okay, okay. Yes. When you send Sanchita, you also let me know, please. Okay, nice. Now this reaction, now you have to draw this. Three. Please let me know when you're done, both of you. Sanchita, always tell me when you,
Um,
when you
I'm just
send me.
sending it.
Yes, yes, you sent 2 minutes back. Send it straight actually because I'm watching it on the laptop, so I have to turn my head. Okay. I don't think so. Can I turn it, rotate? No, I cannot rotate it. Okay. Sanchita, in the second one, it will be CH3NH2 minus, right? See, if the left hand side has -1 charge, right hand will also have same charge. Okay. CHPR CH3OH. Okay, C is correct. D is also correct. Very good. Now next is position of equilibrium. We know which side strong to weak. Okay. For example, in this example, what is which one? This is the stronger acid, so it will go like this, strong to weak, right? So that is why on the left it will lie, right? Okay, let's do. So this is the next question. Problem 4. Which of the reactions in problem 3 favor formation of the reactant and which favor formation of the products? Okay. So we know that it goes from strong acid to weak acid, right? Come on. You have to know the pK values. Have you done, Sanchita?
Sir, I'm still doing.
Okay, okay. Okay, please send me your answers. Okay, then we'll meet tomorrow. Okay, we continue with this. Okay, take care, have lunch. Okay, bye.
Thank you, sir. Bye.
Bye.